Please go ahead and pause the video and reconsider the question for a moment if you haven't done so already. We're asked to express the number as a ratio of integers, and the key to doing this is to begin by separating the portion of the number that doesn't repeat from the portion of the number that does. So we can actually rewrite this as follows. We've sort of color-coded the repeating portion in blue and the non-repeating portion in red. And then what we need to do is to rewrite the repeated portion as a geometric series. To do that, we'll notice that the first occurrence of 35 goes out to the first, second, third decimal place. So we can actually write that as 35 over 10 to the third. The next occurrence of 35 goes out to the first, second, third, fourth, fifth decimal place. So that can be written as 35 over 10 to the fifth. In following this pattern, we're going to be able to write all occurrences of 35 in the following manner. And to kind of link them together, we simply add them. And so this is just another way of writing the original number, and this still goes on forever. The purple portion here is an infinite geometric series. And we know it's geometric because we keep continuously multiplying by a common factor, which in this case is 1 over 10 squared. So if you'll notice, we keep multiplying each term successively by 1 over 10 squared to generate the next term. This constant number by which we are multiplying is known as r, and so in this case r is equal to 1 over 10 squared. It turns out if the absolute value of r is less than 1, then there's a special formula that we can use to kind of condense the purple portion of this number. Let's take a look at that formula. So I've color-coded that in purple to remind us that that corresponds to the infinite geometric series portion of our number, which is also in purple. Now a represents the first term of the geometric series, which is 35 over 10 cubed, and then r, we already noted, was 1 over 10 squared. So let's go ahead and fill in those numbers for both a and r. There we have it, and that is a ghastly complex fraction, but we can simplify it if we multiply the numerator by 10 to the third and the denominator by 10 to the third, remembering that we have to distribute this 10 to the third to both the 1 and to this fraction here. So let's see what that would look like. Now this, of course, is 10.1 plus 35 over 990. And then we've got to find a common denominator of 990 to add these two fractions together. So why don't we go ahead and multiply this fraction, denominator and numerator, by 990. And then simplifying a little bit further, gives us this result, and we'll notice both numerator and denominator are even, so they're divisible by 2, and so if we divide them both by 2, we get the final answer.